Hello everyone, and welcome to Algebra 1 with Mr. Wilmoth, my first Algebra 1 YouTube video. Alright, so before we get started with any of that, we're just going to talk about what some of these words mean. So our first word is going to be monomial. Mono means one. So if we think about like the word monocle, look at my fancy guy here. A monocle is glasses, but it's just on one eye because mono means one. We can think of lots of words that could start with mono, like monogamous. That starts with mono. It means that you're only going to marry one person. You're only going to be in a relationship with one person. So a monomial is going to just be one term. So it could be something like 3, that's one term. Or it could be something like 3x squared y. Because there's no pluses or minus, this is still one term. Bi means 2. You probably think of some words that start with bi. Bicycle. So a binomial has 2 terms. Let's just kind of combine these two together from the last problem, or the last example. If I put a plus in between them, now this is a binomial. 1 and 2. Tri means 3. Let's stick with the bike theme. That could be like a tricycle. And a trinomial could be like x squared minus 3x plus 7. It's trinomial because 1, 2, 3 terms. Poly is our last one. It just means many. So poly, we could think of like a polymer. It's like a plastic, but it's a complicated plastic is what it is. Polynomial just means it has many terms. So poly, like this term is a polynomial, this term is a polynomial, just because it has more than one term. But it could be like x plus 7, or it could be x to the 100th plus x to the 99th plus x to the 98th. Oops. Plus dot dot dot. All of those. Plus 1. All right. So it says here the prefix for a polynomial is determined, or sorry, the prefix for the polynomial, meaning like mono, bi, or tri, is determined by the number of terms. Terms are separated by a plus or a minus. You could have probably figured that out here. Plus or a minus. Monomials cannot have a negative power. Okay, so none of the monomials in the term can have a negative power. So if I had this as -1 here, this is no good anymore because that's a negative power. So let's scroll down here. Oh, geez. Jumping all over the place. Okay, so an example. Let's mix up our colors here. Okay, it says the degree of a polynomial is the greatest degree of any of its terms. So let's say here we have like x. Oh, the animals are going to be making some noise here. X cubed minus x to the 5th plus 7. If I look at these 3 terms here, the power is a power of 5. Okay, it's a power of 5 because the highest power out of the 3, the 5, and this is x to the 0 power, the highest power is 5. It gets a little bit more complicated if I start looking at terms with more than one variable in them. So let's say like we have 3xy squared minus 2x squared y squared plus let's say x to the third. So if we look at it, at first glance, it looks like this x to the third is going to be my highest degree, my highest power, because that's the highest one. But actually, this also has a power of 3 because I'm going to combine these total powers, and the actual highest power is 4 because the highest power is x cubed, or x squared y squared, which is the power of 4. It'll make more sense as we get going here. Where is my mouse? Just trying to scroll down. It's jumping like crazy. All right. So let's try the next problem. It says here, determine whether each expression is a polynomial. If it is a polynomial, find the degree, and then determine if it's a monomial, binomial, or trinomial. So let's see here. This first one, is it a polynomial? So all I'm looking for, it said, sorry about that, the dog is being kind of loud here. The first question just says, is it a polynomial? So all I'm looking for is the power negative? If there's a negative power, it's not a polynomial. So let's take a look. This one is, this one is, this one is not, C is not a polynomial because it has a negative power. So this one is no, and I don't have to do any of the rest of the problem. Let me draw some lines here. All right. So that's the first one. That's, or C is the easiest one because it has a negative power. I don't have to do anything. All right, now let's take a look at our first one. Is it a polynomial? Yes. All the rest of them are polynomials because they don't have negative powers. Okay, the degree on this one, the highest power is 1 because that's y to the first power. Is it a monomial or a binomial or a trinomial? It has 1, 2 terms, so it is a binomial. Next, this one has no variable. So that's the same as x to the 0 because x to the 0 is 1. So I'm going to say this has a degree of 0. And it only has one term, that is a monomial. This one here is trying to trick us a little bit. The power is easy enough to see. It's 3 because the highest power is 3 out of all my terms here. But this one, I could combine these into 4x plus 1x. That's the same as 5x. So because I can combine these into 2 terms, this is actually a trinomial, even though it looked like a polynomial at first. If I simplify it just a little bit, it's not that bad. So at this point in the video, you should try to do these problems down here by yourself. So I would pause the video for a minute and try to do these 4 problems. All right, so this one had a, well, let's just say which one is not a polynomial. This one here is not a polynomial because of this -4, and this a doesn't make things very easy either. So this one is not a polynomial. The rest of them are, yes, a polynomial, so I'm not even going to bother writing that. This is a monomial with power, a degree of 1 because it's x to the first power. Next here, okay, it looks like 4 terms, but actually these 2 terms can be combined into 1 term. So this is a trinomial, and the degree, I wrote power before, but it should be degree of 2 because of this 2 right here. This is our tricky one here. It's a binomial. That's easy enough because there's 1, 2 terms. But it looks like all of them have a power of 1. This right here has 2 powers of 1, so that's a degree of 2 on that one. And this one has a degree of 3. I always pick the biggest one. So the degree is 3. 1, 2, 3. All right. Nice job there. I'm assuming you got it right. It's hard for me to tell, though. Scrolling down a little bit here. Now it asks us to write this in standard form. Standard form is pretty easy. Standard form just means we want all of our degrees in descending order. So if I look at A here, the highest power, I've got a power of 2, a power of 5, and a power of 1. So out of all of these, I'm just going to write it with the 4x to the 5th in the first spot, plus 3x squared minus 7x. All I did was rearrange everything so my highest power is first, and then my next highest power, and then the negative 7x stays at the end. That's it. So it's just write each in standard form, and it does say identify the leading coefficient. If you don't remember, a coefficient is the number that's in front of a variable. So my coefficients are 4, 3, and negative 7. The leading one, you could probably guess, is this 4 because it's the very first one if it's in standard form, with the highest power being first. So the answer on this one is 4. Okay, let's try the next one here. Looking at all my powers, negative 2y to the 4th is the highest power. Then I've got the negative 6y cubed. And then I've got my 5y. Now the 5y is a little bit tricky because it doesn't have a symbol in front of it, but since it's positive, we're just going to write that it's plus 5y, and then finally minus 9. And now my leading coefficient is negative 2. Okay, at this point, again, try pausing the video, see if you can do these two problems here. All right, when we write it in standard form, we get 2x to the 4th minus 2x squared minus 3x plus 8. And the leading coefficient is 2. This one here, my highest power is negative 7y to the 6th plus 5y cubed minus 2y squared plus y plus 10. And the leading coefficient is negative 7. Okay, so today we are learning how to add and subtract polynomials. We haven't done any of that so far. We've just practiced writing, like identifying what each of the terms are and what the powers are, and whether it's a monomial, binomial, or trinomial. So now we're going to actually add and subtract the polynomials. Adding the polynomials is going to be real easy. So, okay, when I add the polynomials, I have this trinomial plus this trinomial. These parentheses are here for no reason at all. So we can just do 2x squared plus 5x plus 7, or minus 7, plus 3 minus 4x squared plus 6x. The parentheses have no purpose. Now I'm just combining like terms. I've got a 2x squared and a minus 4x squared. If I add those two together, 2 minus 4 is going to give me negative 2x squared. So now let's try the next term. Plus 5x plus 6x, that's going to be plus 11x. And then finally, minus 7 plus 3 is going to be a minus 4. So my answer is negative 2x squared plus 11x minus 4. I'll do one more here with you. I'm going to skip the step where I rewrite it without the parentheses because that didn't do anything. I was just trying to show you that the parentheses don't matter. The parentheses will matter when we start multiplying. But right now, when it's adding, and when we subtract, they'll matter too. When we're adding, the parentheses don't do anything. All right. So let's take a look. First, I'm just gonna look for my highest power so that when I'm done, everything will be in standard form. The highest power I see is this y cubed plus 2y cubed. If we remember, the coefficient there is 1. 1 plus 2 is going to give me 3y cubed. Now I want to say, okay, I got those out of the way. Let's see about y squareds. I got y squared. There's no other y squared, so I'm just going to write plus 4y squared. Did that one. Okay, let's look for the y's. I got 3y minus 4y. 3 take away 4 is negative 1y, which I can write as minus y. And then finally, I've got my minus 5 and plus 8. Minus 5 plus 8 is going to be a total of positive 3. That's it for that term, or for that problem. At this point, you should pause the video and see if you could do these problems here. We should have ended up with 2x squared plus 3x plus 1. And then on 3b, we should have had negative y to the 4th, and then 2y cubed. There's no y squareds. Negative 3y plus 2y is negative 1y. And 7 take away 11 is going to be negative 4. All right. Hopefully you got those right. Now we're going to look at subtracting polynomials. Subtracting polynomials is not going to be that much different, but there is one additional step. So see how we have the negative here? Anytime we have a negative outside of parentheses, it's just like having a number outside the parentheses. That's a negative 1 here. So I have to distribute negative 1 times all of these terms. So this will be negative 4x, and negative times negative is a positive, so I got positive 5, and then a negative times a positive is negative 3x squared. So I distributed the negative, which changed all of the signs of everything inside the parentheses. The first polynomial, it does not have a negative outside it, so we're just going to write every single term the way it was. And now I just do this problem just like we did the last one. So I've got 2x squared minus 3x squared is going to be negative 1x squared. And then I've got, let's pick some new colors here. I've got negative 2x minus 4x is negative 6x. And then finally, 3 plus 5 is going to be plus 8. Okay, so again, to recap, we just take this negative and distribute it to each of the terms, which gives me negative 3p squared on this one, minus 2, and plus 9p. The first polynomial stays the same. And now we just combine the like terms like we did in the first problem. Nothing combines with the 4p cubed. I've got a negative 3p squared that nothing combines with. I do have a 7p and a 9p, which will add up to 16p. And then minus 8 plus or minus 2 is minus 10. Okay, again, it would be a good point to pause the video and try this last problem yourself. Okay, we should have distributed the negative. And keep the first polynomial alone, not changing anything. Now I'm going to combine these terms here. 6x cubed minus 3x squared, and minus, that's a 1x squared there, so I have minus 4x squared. I've got a plus 6x that doesn't combine with anything, and then minus 4 plus 2 is going to be minus 2. All right, so now we're just going to look at our real-world example here. And I looked at this problem. I don't know why we would want to do a problem like this, but like in the real world, why we want to look at the total number of phones and consoles sold, but that's what the problem's asking us to do. The equations P equals, let's see, the equations P equals 7m plus 137 and C equals 4m plus 78 represent the number of smartphones P and the number of gaming consoles, C, sold in M months. Now I just highlighted those so we could see what do these letters actually mean, because at the end it's going to ask us a question about what they mean. So then it says, write an equation for the total number of monthly sales and then predict the number of total phones and gaming consoles sold in 10 months. So first thing we have to write an equation for the totals. So T is going to be, well, I know that the phones is 7M plus 137. That's phones. And then I've got my gaming consoles, which is 4M plus 78. Now, if I want to find the total of those two, you just add them up. Okay, now we're adding polynomials. I think the book probably would have put these in parentheses, but there's no need to do that, as we already discussed. Now we just combine the like terms. 7M plus 137 plus 78, which is 137 plus 78, 215. So we have 7M. The total is 7. Oh, why did I write 7? Not 7M. 7, 8, 9, 10, 11M. Because I had to add the 7 and the 4 together. Well, I don't know what I was doing here. So this is the first part of the answer. It says write an equation for the total number of gaming consoles. Then predict the number of smartphones and gaming consoles sold together in 10 months. Well, the months is this M right here. So after 10 months, the total is 11 times 10 months plus 215, which is going to be 110 plus 215, which would be 325 total, I'll just say, devices sold after 10 months. All right, so at this point, pause the video, try and read this problem and figure out if you can see what it's asking and answer it. Okay, so it did say use the equation from before. Oh wait, it says use the information to write an equation that represents the difference between them. Why would I care about the difference between them? All right, we're going to find the difference. Equals, we're going to do 7M plus 137 minus 4M plus 78. And I have to distribute the negative to each term. So we have 7M plus 137 minus 4M minus 78, which is going to give me 3M if I combine the 7 and the negative 4, and then 137 minus 78 is 59. And then it says predict the difference after 24 months, which is 2 years. So this is our answer for the difference. But we want to know what's the difference after 24 months. 3 times 24 minus 78. And I'm just going to do all of it, or not 78, 59. Let me just do this whole thing in my calculator. And it gives me a difference of 13. All right. So at this point, you should try to do the check your understanding problems right here. And you can kind of see here it says this problem corresponds with example 1, this corresponds with example 2, and these correspond with example 3 and 4. Okay, pause the video now and try and do those. Okay, number one, these problems are asking, is it a polynomial, just like the first one? This one is a trinomial with a degree of 3, because this one has a degree of 3, so the degree is 3. This one is also a trinomial with a degree of 2. This is a monomial with a degree of 2, because the power here is 2. It only has one term. This one is not a polynomial because you're not allowed to have variables on the bottom. This one is a binomial with a power of 1, 2, 3, 4, 5, degree of 5. And this one, not a polynomial. Okay, and then let's look here. Let's pick a more fun color. What do we got? Let's get some real purple. Write this in standard form and identify the leading coefficient. Well, this one is in standard form. No, it's not. 2x to the 5th. I got to move my 3x over. Minus 12. Leading coefficient is 2. This one here, we have negative 4 d to the 4th minus d squared plus 1. Leading coefficient is negative 4. Here we have 4z minus 2z squared minus 5z to the 4th. Negative 5z to the 4th is our first. Make sure you keep the negative with each term. The sign is attached to the coefficient it's right with. Minus 2z squared plus 4z. And we have a leading coefficient of negative 5. Finally, here we have 4a cubed minus 5a squared plus 2a minus 1. Leading coefficient is 4. Now we're going to find each sum or difference. We're just going to combine our like terms. 6 minus 2 is going to give us 4x cubed, and then negative 4 plus 9 is going to be positive 5. So we've got g cubed, nothing combines with that. Negative 2 minus 1g is going to be negative 3g squared. I've got 5g plus 2g is 7g, and then plus 6. Here it's a negatives or minus, so I have to distribute the negative. 4 plus 2a squared minus 2a minus 3a squared plus 8a, because it distributes, the sign changes, minus 7. So that's an a squared there. So anyway, I've got the 2a squared minus 3a squared is going to be negative 1a squared, because 2 minus 3 is negative 1. Then I have negative 2a plus 8a is going to be plus 6a. And then finally 4 minus 7 is negative 3. This is a plus, so I don't have to rewrite it. 8y combines with a 3y, I get 11y. Negative 4 minus 9 is going to be negative 13y squared. This one is negative, so I have to change all the signs. Negative 4z cubed minus 3z squared minus plus 5. I almost made a mistake. And then I just copied on everything else. So now I'll combine the like terms. Negative 4 minus 4 is going to give me negative 8z cubed minus 2z. Oh, wait. There's a 3z squared here. So next I have negative 3z squared, then minus 2z, and then I've got 8 plus 5 is 13. Last one here, it's plus, so I don't have to rewrite it. Let's combine our like terms. Negative 3d plus 1d squared is going to give me negative 2d squared. Negative 8 Oh, sorry, let's look at the d's next. 2d plus 4d is 6d. And negative 8 minus 12 is going to give me negative 20. All right. That is it for chapter 8.1. And we'll go over any questions you have when we get back.